All right. So over the past couple weeks, we've been talking about chemical bonding. Why do atoms bond with one another? Why do atoms bond with one another? Go there.
To get to 8 valence.
8 valence electrons. And why is 8 valence electrons important?
Because that's when it becomes
Go ahead. Say again.
That's when it becomes stable.
Makes them stable, low energy state, right? So let's start off with an atom that we have talked a lot about while we've been doing this, right? And maybe my pen will work, maybe not. Oh, there we go. Okay. All right. And here's sodium. All right. So sodium, we know, based on its location on the periodic table, has how many valence electrons? 1. Right? Group 1, alkali metal, 1 valence electron. And there it is. Okay. What is sodium looking to do with that valence electron? Get rid of it, right? Okay. Then, oh, it's not what I wanted to do. Then there's oxygen, all right? Based on oxygen's position on the periodic table, how many valence electrons? 6, right? So we'll draw those in here, okay? And boom, 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 boom. Okay, good there? And we know that if it had 6 valence electrons, it's looking to do what? Gain 2. Okay. All right, next, let's bring in hydrogen. Based on hydrogen's position on the periodic table, how many valence electrons does it have? 1. Although hydrogen's a little bit different than sodium. They both have 1 valence electron, but why are they different? Good.
Hydrogen's looking to gain 1 more.
Hydrogen's looking to gain 1 more, whereas sodium is looking to lose it. Why is hydrogen looking to gain where sodium's looking to lose? David, go ahead.
Because slow shell.
Really? Anything else?
Because like PS orbital only contains 2. So.
Good. So, okay. Sorry. Also, we could also look at what kind of an element is hydrogen versus what kind of element is sodium. Non-metal versus metal, right? Non-metals gain, even though sodium is way over on the far left, or sorry, even though hydrogen is way over on the far left, it's a non-metal, right? So it's looking to gain. Okay, good there? All right, let's start putting pieces together. Ultimate goal here is for everybody to get where? 8 valence electrons, although we said in hydrogen's case, 2, right? So, oxygen, hydrogen, right? What's going to happen there? Well, what are oxygen and hydrogen both looking to do? Gain electrons, right? What kind of bond forms when 2 atoms are looking to gain electrons? Covalent bond, right? Okay, so this is going to happen first. Well, maybe not, but let's just go with this for now, okay? So we got a covalent bond there, right? And we can represent that covalent bond like this, right? We said the line represents what? Shared what? How many shared electrons? 2 shared electrons, right? A pair of shared electrons, okay? All right. Is hydrogen all good? Yeah, hydrogen's good. Is oxygen good? No. If there was another hydrogen around, it would form another covalent bond, and it would make water, right? Yes, so maybe? Okay. But there isn't another hydrogen around. But what is there around? Sodium. What's sodium looking to do with that valence electron? Get rid of it, right? Oxygen's looking to pick it up. So then this happens, right? This is the makings of a what? This is not the makings of a molecule. This is the makings of a, not a molecular compound. What? Well, sort of. This is the mechanics of how we formed a what? An ionic bond, right? What's happening to that electron there? Is it being shared or is it being transferred from one thing to another? Totally being transferred from one thing to the other. Okay? Does that make sense? But just the transfer of the electron doesn't cause an ionic bond. Transferring electrons creates what?
Charge.
Charge. What do we call those charged atoms?
Ions.
Ions. Transferring electrons creates ions. Okay? Sodium. What kind of an ion is it going to be? Cation, because it's going to have a positive charge, right? And specifically, how many positive charges does sodium have now? Just one. It's 1 plus. Right? Good there? Okay. Now, let's talk about oxygen. All right? Is oxygen full with its 8 valence electrons now? What did you ask? Yeah, I thought you should know. I was like, all right, so oxygen's full, but part of oxygen being full depended on the fact that it had already formed what with hydrogen? A covalent bond. These two are stuck together. We can't separate them because if we separate them, now they're not happy anymore, right? They're not at that low energy state. So now these two are a package deal because they're already covalently bonded together. Does that make sense? Then you got oxygen and its valence electrons, and then it's 1 valence electron, but then also it now has the valence electron that it picked up from sodium. Yes? Does that make sense? Here, this group of atoms right here, is everybody happy? Everybody's happy. But in order to make everybody happy, we had to pick up an electron along the way. Yes? Is this an ion?
Yes.
Yeah. What are ions? What's our definition of an ion? Something that has a what? A charge, because it has more electrons than protons or vice versa. Within this entire group, are there more electrons than protons?
Yes.
There are. And that means that that whole group has a what? A charge. Specifically, what charge?
Negative.
What did it do? It gained electrons, so it has what kind of a charge?
Negative.
A negative charge. How many electrons did it have to gain in order to make everybody happy?
1.
It didn't actually gain electrons here, right? They're just sharing here. But it only picked up 1 electron along the way. Does that make sense? This whole group of atoms, it's only 2, but this group of atoms now has a negative charge, specifically a -1 charge. So, what do positively charged ions and negatively charged ions do to each other? They attract. Opposites attract. Whether we're talking about single atoms or whether we're talking about a group that has picked up an electron along the way. Good? Yeah. So now we form a compound that looks, with all of this right here, right? We form a compound that looks like this. Okay? Is that a molecule? Eric says no, he's right. Why is that not a molecule? Somebody else tell me why Eric's right. NaOH is not a molecule. Why not? Doing good.
Because there's not more than one.
What else? Austin,
Irrelevant.
what were you going to say? Come on, what were you going to say? You were on, I think you were on the right track. They're all not what? Come on, what were you gonna say? All right. So, Liam.
They're not all non-metals.
Okay, they're not all non-metals. And that means not all of the bonds in there are what kind of bonds?
Covalent.
They're not all covalent bonds. This is a combination of ionic bonding and covalent bonding. But at the end of the day, is everybody happy? Everybody's got 8 valence electrons. I don't care how they get there, they just get there, all right? So this is our introduction to today's topic, and especially this group right here, the O and the H that originally formed a covalent bond, but then picked up an electron from sodium. Is this an ion? This group of atoms together, is it an ion?
Yes.
Yes. How many atoms are in that ion? Well, this right here, how many atoms are there? 2, which is more than what? More than 1, which means we call this group right here a, what was the topic for today?
Polyatomic ion.
A polyatomic ion. Does that make sense? Good how we got there? Okay, go ahead, Doug.
So if you were supposed to tell what elements are in that and you just saw oxygen and hydrogen, you couldn't know if it had sodium in it?
Well, these two together, okay, so let's start back up here. Okay, let me highlight this section up here. Okay. All right. That group right there, okay, the oxygen and the hydrogen before anything else, right? Hydrogen's good, but oxygen's not, right? So oxygen still needs to fill this space right here, right? It will look for an electron wherever it can get it, okay? Like we said, another candidate to fill that spot might be another hydrogen that came around, right? Does that make sense? If another hydrogen came around, it would form a covalent bond with that other hydrogen, and then we would have H2O, we'd have water, right? But there wasn't another hydrogen around, so it looked for anything else that will fill that spot. This sodium is looking to get rid of that, so it donated that to the space, and when it did, then it became an ion.
That's not what I was asking.
Okay, sorry.
So you know at the bottom where it has like O and then the line, you wouldn't know that it's sodium if you were asking us.
Technically, right, correct. I wouldn't know that it was sodium.
So you wouldn't
Any-
ask us that.
Any candidate, like any atom that is looking to lose 1 electron could donate that there, right? Yeah. This doesn't just happen with sodium. This could happen with any atom that's looking to lose an electron, and that's kind of where we're going to end up today. All right, so kind of keep that in mind as we go forward here, right? Yeah, I just knowing that O bonded to H, picked up an extra electron. Yeah, you don't know where it got that extra electron from necessarily. You just know that it got an extra electron because it needed it to get oxygen to 8 valence electrons. Okay, we'll talk about how that affects formulas later on today. Okay? All right, so let's go here. Okay, representing ionic chemical bonds. We're back to ionic bonds because we've transferred electrons. But along the way, we had some covalent bonding, and that's where we get the polyatomic ions. So we're kind of blending both of them together. Right? So the slides that I gave you on the back of the page that you may have been drawing on, that's where we are right now. Okay? So a polyatomic ion, by definition, is a group of covalently bonded atoms that has a positive or negative charge as it acts as one unit. So that's the thing that we have to kind of remember here, is that this is a group of atoms. They are bonded together. They act as a single unit, but they have a charge, and that means that they are attracted to other charges. That group of oxygen and hydrogen that we just talked about in the previous drawings at the beginning, we call that hydroxide. The hydroxide is the one oxygen, one hydrogen, covalently bonded together, but have picked up an extra electron somewhere along the way. Okay? The next one down we call sulfate. Sulfate is one sulfur, 4 oxygens that are all bonded together covalently. But between that one sulfur and those 4 oxygens, hold on a second on the chart. I'll get you guys the chart. Hold on a second. Let me finish talking about this, then we can fill in names. All right. Between that one sulfur and those 4 oxygens, there aren't enough electrons to make everybody happy. There aren't enough electrons to get everybody to 8. So what do? They pick up 2 electrons. From where? Who knows? Could be 2 separate sodiums, each one donating 1 electron. Could be a calcium that donated 2 of its electrons. Does that make sense? We don't know where it got those 2 electrons. All we know now is that it has them, so it has a negative charge now. Okay? Same thing down here. Nitrate, 1 nitrogen, 3 oxygens. There aren't enough electrons between those 1 nitrogen and 3 oxygens to make everybody happy. So what do? They got to pick up an electron from somewhere. Where? Anyone that's willing to give it up. Right? Good there? So these groups act like a single unit. All right? On your outline, you have this chart. It didn't copy as well as I wanted it to copy. So I will tell you this, okay? You will not need to memorize all of these, not in this class. When you get to chemistry, guess what? You're going to have to memorize this list and probably 10 more, okay? There are certain polyatomic ions that show up with more frequency than others. In this class, I will give you the chart on the test. I will tell you the formulas. I will tell you the charges. But someday soon, whether that's next year or whether it's when you're a junior and you take chemistry, you're going to have to memorize these things, okay? And you'll notice that some of them are very similar, like nitrate and nitrite. One's NO3, one's NO2. Okay? Why? They're just different. These atoms find different ways to make that combination to get everybody to 8 valence electrons, right? Chlorate, chlorite, right? Very similar, but one's 3 oxygens, one's 2 oxygens. Okay? Why? Just how it happens. Okay? These are all what we refer to as polyatomic ions. Several atoms that are bonded together covalently that then pick up extra electrons from somewhere so they become negatively charged. Right? Good there? Okay? All right, so what do we do with these things? Once we have these ions that are formed, right, the extra electrons that they picked up makes everybody happy, stable, 8 valence electrons. But it leaves them with a charge. And if they're negatively charged, what are they attracted to? Positively charged things, right? These are like it says on the table, right? Polyatomic anions. Polyatomic anions are attracted to what? Cations, because cations are positively charged. All right? Does that make sense? Okay. So how do we represent that? That's where we're headed here next. Okay. All right. So, and there's not a lot you have to write down here, so you can just like listen if you want to make some notes or whatever. Okay. Formulas for compounds with polyatomic ions. So, all atoms in a polyatomic ion need to be written, but the charge comes with the entire group. Notice in capital letters. Okay. That negative charge on hydroxide, OH -1, that negative charge doesn't come with the oxygen, and it doesn't come with the hydrogen. It comes with the group as a whole. Okay? So the charge is not assigned to one specific atom in the group, but to the group as a whole. They act together as a single unit. Even though it's 2 atoms, or it's 3 atoms, or it's 4 atoms, depending on how many are bonded together, they come as a package. All right? So, what is the formula for the ionic compound formed between sodium and the hydroxide ion? Well, that's what we drew at the beginning of class, right? How many sodiums do we need to make this hydroxide ion happy? 1. And so the formula would just be NaOH. Okay? Good with that so far? All right. Let me give you another one. So, we just saw that that happens first. Is that a polyatomic ion as I have drawn it? Not. Right? Because all oxygen and hydrogen did was share those 2 electrons. We haven't picked up anything along the way yet. Okay? And let's say this happened here. Okay? On a separate oxygen, a separate hydrogen, right? Covalent bond. But again, are those stable? No. Oxygen keeps looking for one more electron, right? Luckily, for these 2 groups of atoms, calcium came around, right? Where's calcium on the periodic table? Group 2. How many valence electrons? 2. It's looking to get rid of those 2, right? Okay. So what happens? What happens? It loses them, right? But 1 to each, right? This electron that calcium is trying to lose goes here. This electron that calcium is trying to lose goes here. Okay? Now, individually, what are those? Those are polyatomic ions because they've all gained that electron. Okay? Good there? But, and specifically, do you remember what we called those polyatomic ions? Those ones had a name. Those are hydroxides. Okay? How many hydroxides does this calcium need to lose all of its valence electrons? 2. So it's a 2-to-1 ratio. Okay? So we know that formulas tell us what's in the compound and the ratio of things in that compound. So we know there's calcium and we know there's hydroxide. Okay? But how many hydroxides do we say we needed for that calcium? 2. We show the ratio by using what? Subscripts. Okay? This is how we do it with a polyatomic ion. Remember, these are a group. They come together. We can't separate them. So the subscript, we don't put it there because that represents 2 oxygens and 1 hydrogen, and that's not what's here. We don't put it there because that represents 1 oxygen and 2 hydrogens, and that's not what's there, right? When we represent the multiple polyatomic ions, we put that polyatomic ions in parentheses, and then we go there. Okay? Does that make sense? Good with that? So, to continue on with our notes, which is that I believe in the bottom left-hand corner of yours slides that I gave you today, right? If more than one group is needed, the formula for the polyatomic ion is written in parentheses, and the subscript is written outside of the parentheses. Okay? What's the formula between the ionic compound formed between barium and the hydroxide ion? Well, I didn't do barium for you, I did calcium, right? But if you find barium on the periodic table, where is it? Same group, right? So if calcium and hydroxide was Ca parentheses OH2, what do you think barium's going to be? Ba parentheses OH2. Okay. Good there? So, naming compounds of polyatomic ions. Compounds that have polyatomic ions are ionic compounds, right? Name of the cation comes first, right? So, in this case here, right, if you look on your little chart, SO4 is called sulfate. So when we're naming this compound, the cation comes first. So what will we have to write first? Calcium. And then the name of the anion comes second. But we don't change the ending here because we keep that group as a whole. So this is calcium sulfate. This didn't come up in the order that I wanted it to come up. All right. Good there? So all we do there when we're doing polyatomic ions is just form the two groups together, right? Form the name of the two groups together. Okay? Good there? All right. Let's do a couple of examples just to see how this all fits together. Okay? Grab out the grid that I gave you today. The one that looks like this. Okay. All right. I'm just going to take a little part of this here. Actually, I should do this. My bad. Okay. So up at the top, you have your polyatomic anions. Okay. We just learned about hydroxide. What's the symbol for hydroxide? OH. And then its ionic charge is what? -1. Okay, so -1. Okay. Sulfate. Sulfate is SO4, and it's -2. So you can write -2 or 2-, totally up to you. Remember, that comes as a group, right? All right. Phosphate. PO4, 3-. Okay. Carbonates. CO3, 2-. And then nitrate. NO3, -1. Okay? Good there? All right. Left-hand side, these are your cations. Calcium, I hope you know calcium by now, right? Calcium's what? Ca. And based on its position on the periodic table, what is its ionic charge going to be? 2+, right? It's going to lose 2 electrons. All right. The next one down, ammonium. There's a couple, but there's only really one polyatomic cation, and it's ammonium. So it's polyatomic cation, so it's NH4, but then that group has a +1 charge as a group. Okay? And then I hope you guys can do potassium and aluminum just based on where they are in the periodic table. Okay? So find potassium. Fill out those last two, and then we'll get doing some examples. So what charge is potassium going to have? +1, right? And then aluminum is going to end up as +3. Okay. All right. Let's start making some formulas. Ready? Here we go. Okay. So we already we talked about this one in the top left, right? Calcium is looking to lose 2 electrons, right? That's why it has that +2 charge. Each hydroxide can only pick up 1 electron. So what does the ratio have to be between calcium and hydroxide? 2 calciums, sorry, 1 calcium, 2 hydroxides. And we saw we use the parentheses to represent that. Okay. As far as the name goes, we just take the name of the cation, which is what? Calcium. We take the name of the anion, which is hydroxide. So the name of that compound is calcium hydroxide. Don't change the ending of the name of the polyatomic ion. We just keep the name the way it is. Okay? All right. So next, calcium plus 2, sulfate minus 2, meaning sulfate, that group of 1 sulfur and 4 oxygens that are covalently bonded, had to pick up how many electrons? 2. How many electrons did calcium have to give away? 2. So what's the ratio between those two going to be? 1 to 1. Even though each individual charge is 2, the ratio between them is 1 to 1. So calcium sulfate. If we don't need more than 1 sulfate, we don't use the parentheses. All right? If you don't need more than 1 sulfate, you don't use the parentheses. Okay? All right. Ready for the hardest one on the sheet? Well, one of the hardest ones on the sheet. Okay? So, calcium's looking to lose 2 valence electrons, but phosphate, group of 1 phosphorus atom and 4 oxygen atoms that are joined together, how many electrons did it have to pick up? 3, right? We've encountered this situation before, right, where we have a +2 and a -3, right?
Would it be Ca2, PO, or no, it'd be Ca3, PO4 in parentheses 2.
Okay. Does that make sense? When we have that 2 positives, 3 negatives combination, right? We talk about the lowest common multiple that we can get to is 6, right? We need 3 calciums to get to 6 positive charges, but then we need 2 phosphates to get to 6 negative charges. What's the name of that compound going to be? Calcium phosphate. The ratio doesn't have any role in naming that compound. Okay. Good there? All right, next, I want to do one more for you. Okay, let's do these two, sulfate and ammonium. Okay, both are polyatomic ions, but one's a polyatomic cation and one's a polyatomic anion. All right, so sulfate is looking to gain 2 electrons, or it has gained 2 electrons. How many electrons has ammonium lost? Just 1. That's why it has that +1 charge, right? So how many ammoniums do we need to balance out that sulfate? 2 ammoniums for every 1 sulfate. Does that make sense? All right. So if we need, what part of an ionic compound always comes first in the formula? The cation. Even though this is polyatomic, it's still a cation. So it comes first, NH4. But how many NH4s did we need? 2. So what do? Put in parentheses, and the 2. How many sulfates did we need? Just 1. No, any parentheses there? No parentheses there. Okay. Pop quiz. Not to turn in. Pop quiz. How many atoms are bonded together in that compound? Talk to the person next to you. How many atoms are bonded together in that compound?
2. 3.
Not elements. How many atoms are bonded together in that compound?
6. No. 10. No, it's 8. It's 6, 8, 10. Oh no, it could be. What changes the ending? Is that like multiplied like ATEIT?
How many oxygens are bonded together to the central atom?
Is oxygen and everything?
Yes. Well, because it's really reactive and it really wants those 2 valence electrons. So it will bond with pretty much anything to try and get them. All right, are we ready, everybody? Final answer. How many atoms are in this compound? 15 atoms in that compound. How many atoms are in each ammonium ion? There are 5. 1 nitrogen and 4 hydrogens. But how many ammonium ions are there? That means there's 10 plus the additional 5 from the sulfate. There are 15 atoms that are bonded together. But at the end of the day, what's true about all of them? They all have what? Well, because you're on the right track, baby. But some of those atoms that are in there are what?
Stable.
Well, all of them are stable, but some of them are what element specifically? Does hydrogen have 8 valence electrons?
No.
No. But they are all stable, right? They all have full valence shells. It's just that hydrogen only has 2 as opposed to 8 because it's small, right? All right, good there?
Yep.
You have approximately 12 minutes until the end of the period. If you want to finish up this grid, that's all I got for you for today, right? I'll put answers up on the board here in a second. I think there is a couple of questions of homework on the calendar. It's a little bit of reading, and then there's a couple questions of homework. We will do more practice with names and formulas of polyatomic ions on Monday, all right? Feel free to work with each other if you need to, or if you want to. Or if you don't want to, then don't.
What?